Today, we're diving into one of the biggest mysteries in astrophysics: why the forces within galaxies don't add up. Galaxies, despite obeying the laws of gravity that work pretty well everywhere else in the solar system, are spinning much faster than what we'd expect by applying Newton's law of gravity to visible matter. To prevent galaxies from flying apart, there needs to be some additional gravitational force. Hence, the idea of dark matter, an invisible substance, was first proposed. But nobody has seen these things, and in the highly successful standard model of particle physics, there's no particle that could be dark matter. It must be something quite exotic. This led to the emergence of the rival idea that galactic discrepancies stem from the breakdown of Newton's laws. One of the most successful ideas of this kind is called Milgromian dynamics, or MOND, proposed by Israeli physicist Mordechai Milgrom in 1982. However, our latest research indicates that this theory might be in trouble. The main assumption of MOND is that gravity starts behaving differently than expected by Newton when it becomes very weak, such as at the edges of galaxies. MOND does quite well in predicting a galaxy's rotation without the need for any dark matter and has a few more successes. However, many of these can also be explained by dark matter while keeping Newton's laws intact. MOND fails to provide enough gravity in at least the central regions of galaxy clusters. However, it provides too much gravity at their outskirts. Instead, assuming Newtonian gravity with about 5 times more dark matter than visible matter seems to fit the data quite well. However, the standard dark matter model in cosmology isn't perfect. There are things it struggles to explain, from the expansion rate of the universe to giant cosmic structures. So, we might not have the perfect model yet. Dark matter seems to be here to stay, but its nature might be different from what the standard model suggests. Or gravity might actually be stronger than we think, but only on very large scales. But ultimately, MOND can no longer be seen as a viable alternative to dark matter as it's currently formulated. It might not be what we want to hear, but the dark side still holds its sway.